So today, we're going to talk about permutations and combinations. This presentation is a courtesy by UPass Education, Inc. So let's first talk about the difference between permutations and combinations. It's actually a question of whether order matters or not. So let's look at an example. Let's say we have three balls with different numbers on them, each numbered 1, 2, and 3. Well, permutations means we will choose two balls from the three and line them up. In this case, order matters. So possible outcomes are the following. So we can either have 1, 2, 1, 3, 2, 1, 2, 3, or 3, 1, or 3, 2. So in total, we have 6 possible permutations. Now, let's talk about combinations. So combinations means we will grab two balls from the three, and in this case, order does not matter. So if we grab 1, 2 or 2, 1, they're considered the same. So this is one possible outcome of combination. Similarly, we'll have 1, 3 or 3, 1, and we will have 2, 3 or 3, 2. So in this case, we will have 3 possible combinations. So as we can see here, permutations and combinations are not the same. Well, let's talk about permutations first. In permutations, we are trying to get how many choices do we have. So let's use the previous example. So we have 3 balls, each numbered 1, 2, and 3. And let's imagine we have to line them up in 2 boxes. So in this case, order matters. Let's look at the first box. So before we choose any ball, all 3 balls are available. So in the first box, we will have 3 possible outcomes. So in the first box, we can either have number 1, 2, or 3. Well, let's imagine, this is very important, let's imagine that the ball in the first box is already chosen. So how many balls do we have left? We have 2 balls left. So in the second box, we will have only 2 possible outcomes. So in the first box, we have 3 outcomes, and for each of the 3 outcomes, we have 2 possible outcomes for the second box. So we combine the 2 boxes together, we have 3 times 2, which is 6 outcomes in total. Well, let's look at a more complex example. Let's say instead of 3 balls, now we have 5 balls, and with each one numbered 1, 2, 3, 4, or 5. And now we have to line them up in 3 boxes. And remember, this is a permutation, so order matters. And again, for the first box, since all 5 balls are available, we will have 5 possible choices for the first box. And once the first box is done, we will have 4 balls left. So when we come to the second box, no matter what our choice for the first box is, for the second box, we'll have 4 possible outcomes. And if the first 2 boxes are already chosen, we will have only 3 balls left. So for the third box, we will only have 3 possible choices. So let's get a quick review. For the first box, we have 5 choices. And after the choice is made, no matter what it is, we'll have 4 choices for the second box. And after this choice is made, we'll only have 3 balls left, so we have 3 choices for the third box. So for each of the choices in the first box, we'll have 4 possible choices for the second box. And for each of the choices in the first 2 boxes, we will have 3 possible choices for the third box. So the total number of choices in permutations is 5 times 4 times 3, which is 60. Now, what about a general example? Let's say we have n balls, and we want to line them up in r boxes. In this case, order matters. So in the first box, similar to the previous 2 examples, we will have n balls left. So we have n possible choices. When we come to the second box, we already chose 1 ball for the first box, so we have n minus 1 balls left for the second box. And similarly, all the way till n minus r plus 1. Well, a lot of students are being confused here. They say, why not n minus r? Well, think about a choice here. So let's say we have 3 balls and we want to line them up in 2 boxes. In this case, our n is 3 and r is 2. So the first box, we have n choices, that's 3 choices. And for the second box, we will have 2 choices, which is not n minus r, because remember our n is 3 and r is 2. n minus r is 3 minus 2, which is 1. But really, we have two choices for the second box. So if we use n minus r all the way till n, then the number of items is not r. In order to make it r, we will have n minus r plus 1 choices. Well, if you're confused about this, you can come to my class and it will be explained in detail. Well, let's come back to this example. So we have n times n minus 1 times n minus 2 times all the way to n minus r plus 1. So this is our total number of choices in permutations. Well, this expression is ugly, so we'll try to rearrange it into a more readable form. So we can write it as n times n minus 1 times n minus 2 times all the way to n minus r plus 1 over 1. So now, let's multiply it by the following expression. So this expression seems meaningless because the denominator and the divisor are identical. So this is what exactly how we want it. So in this case, we times this expression both up and down, and now we combine them together. So the denominator becomes n times n minus 1 times n minus 2 times all the way to n minus r plus 1, and continue times n minus r times n minus r minus 1 all the way 3 to 1. And in the divisor, we will only have the expression itself. So looking at the denominator, we notice that this is actually n factorial, and the divisor is n minus r factorial. So if we give this permutation a notation, saying NPR, that means choose r items from n items in total and line them up, and we call it permutation, then we'll have our formula NPR equals n factorial over n minus r factorial. So now let's talk about combinations. Well, there are two approaches to understand the combinations. Well, I'm going to show you the easier approach. So let's say from permutations, we can derive a formula for combinations. So let's recall that the only difference between combinations and permutations is that order does not matter. So let's recall our previous example. In a total of n balls, pick out r balls and line them up in r boxes. So we'll have our NPR equals n factorial over n minus r factorial. So what if we don't want to line them up? Any order of r balls chosen are treated as the same combination. So in this case, we'll divide the number of possible ways to line up r balls, then we will have our number of combinations. So if we line up r balls in r boxes, well, according to our previous formula, that'll be r times r minus 1 times r minus 2 all the way to 3 to 1. So this is really r factorial. So in this case, if we give a notation to combination, which is NCR, which means choose r items from n items in total, and we'll treat it as a combination, which means order does not matter. Well, according to our analysis above, this is really NPR divided by r factorial. Well, recall that NPR is n factorial divided by n minus r factorial. So our expression becomes n factorial divided by n minus r factorial, further divided by r factorial. Well, we can just write the r factorial in front of it and make it look nicer. So there you have it. The formula for combination is NCR equals n factorial divided by r factorial times n minus r factorial. So after attending this short, free presentation, a lot of students are still confused to some degree. And our complete course is offered, so we can solve your problems on the way. And I promise you, this course will be at the same pace as what you're learning in school. So you enjoy the confidence as you attend our classes, and you get the marks you never dream of in school. And this course is offered by UPass Education. Our official website is upassmath.ca. So remember, it's upassmath.ca. and our phone number is 587-938-1468. And if you have a question, you can send an email to info@upassmath.ca. And thank you for attending this presentation.